So good day to each and everyone. I am Robert Gabriel Sino Tibidan from the group F4. So today we are presenting our facility standard report and audit on a food service establishment called the Gasison Manok and Leempo Station. So this study focuses on evaluating the facility based on design standards, capacity, layout strategy, and location, as well as identifying the operational issues and proposing feasible improvements. The facility we analyze is a small operation specializing in lechon manok, lempo, and fried chicken. It consists of four main work areas, which is the roasting area, the frying station, the display station or the chopping and serving station, and the storage. One important observation is that the entire operation is handled by only one worker, which already suggests that a possible limitation in labor capacity.
Design requirements benchmarking. To evaluate the facility, we benchmark it against standard design requirements from the facility's planning references, such as the Tompkins and the Mother. We measured several environmental conditions inside the facility. The lighting level was 51 lux, which is significantly below the recommended range for food preparation areas. This means visibility may be insufficient for accurate and safe food preparation. The recorded temperature was 31.6 degrees Celsius, which is above comfortable ergonomic levels and can contribute to workers' fatigue, while the noise level of 68 decibels is acceptable. The overall environmental conditions still present ergonomic concerns. The next one is the space and pathway analysis. One of the major issues we identified is the restricted worker pathway caused by the railing position inside the facility. Although the establishment was enough total space, the railing limits the usable pathway to only 89 centimeters on one side. Because of this, workers are forced to take longer and indirect routes when moving products. In industrial engineering, this is considered unnecessary motion and transportation waste. The next one is the ventilation and safety. The facility does have some existing controls, such as the chimneys for smoke exhaust and a fire extinguisher. However, despite this measure, the high ambient temperature indicates that ventilation is still insufficient. This suggests that while some safety considerations are present, the facility does not yet fully meet ergonomic and environmental standards.
Good day everyone, I am Charles D. Puyos. And next is the capacity planning. So we also evaluated the facility's production capacity. According to the owner, during peak periods such as holidays, the facility can produce up to 30 lechon manok, 5 liempo, and 300 fried chicken pieces. However, during normal days, actual production is much lower. So next is the utilization. So based on the actual output, we computed utilization rates of 58.33% for lechon manok, 40% for liempo, and 41.67% for fried chicken. At first glance, these numbers may suggest unused capacity. But in this case, the lower utilization is not because demand is lacking. Instead, it reflects operational limitations within the system. So next is the bottleneck. So the primary bottleneck of the facility is the labor. Since one worker handles the preparation, cooking, and serving, labor becomes the limiting factor in the system. This prevents the establishment from maximizing its available equipment and production capacity. So in other words, the facility is labor constrained rather than demand constrained. So next is the 6M's audit. So to further understand the operation, we analyze the facility using the 6M's framework. This allowed us to evaluate the manpower, machine, material, method, money, and below in a structured manner. So next is the movement analysis. So one of the most critical findings from the audit is excessive worker movement. So it takes approximately 19 steps to transfer fried chicken from the frying station to the display area. Additionally, 11 steps are needed to move skewered chicken and liempo to the rotisserie. These movements add no value to the product and reduce overall efficiency. So next is the spaghetti diagram. So our spaghetti diagram confirms this inefficiency. It shows excessive backtracking and non-linear movement patterns, indicating poor workflow design. This violates the principle of minimum movement in facility layout planning. So that's all for my part. Thank you.
Hazards and improvements. During the audit, we identified several workplace hazards. This includes exposed wiring, slippery floors, hot surfaces, and low ceiling clearances. These hazards increase the risk of electrical accidents, slips, burn, and physical injuries. Addressing these issues is necessary not only for compliance but also for maintaining a safe and productive workplace.
So, the layout problem, the core layout issue is obstructed pathway created by the railing. Its current position prevents direct movement between the back and the front workstations. So this creates congestion and forces the worker to perform unnecessary travel.
So, the proposed improvement is our proposed solution is to relocate the pathway to the center of the facility. This creates a more direct route between station and improves the relationship between interconnected tasks. The redesign follows a systematic layout planning principle by improving adjacency and reducing travel distance. So, the improvement impact. By implementing the proposed layout, the worker's movement becomes more direct, travel distance is reduced, fatigue is minimized, workplace becomes smoother and more efficient. So, the overall, this directly improves productivity without requiring major expansions.
In terms of cost and benefits, We then assessed whether the proposed improvements are practical from cost perspective. Safety improvements such as wire installation, non-slip mats, and signage required only minimal investment but provide significant safety benefits. The pathway rearrangement is estimated to the cost around 2,000 to 3,000 pesos, while this may require temporary closure during improvements. The long-term operational benefits outweigh the small-term inconvenience. In terms of possibilities, technically, the changes can be implemented using the current facility structures. Economically, the cost affordable for small-scale operations. Operationally, the redesigning improvements workflow without redesigning changes to the current business models. In conclusion, our analysis shows that the facility has significant efficiency in layout, workflows, and safety. The current design create unnecessary workers movement, labor bottlenecks, and hazardous conditions. Through benchmarking and practical audit, we identified realistic improvement that can enhance operational efficiency, workers' safety, and overall facility performance.